Hi, my name is Lillian Wilson-Wade, and this is the second Physics 2 lab examining lines of charge. The purpose of this lab was to expand upon what we learned in Lab 1 to further our understanding of charge and its effects on everyday objects and their interactions. Recall that in Lab 1, we determined how much excess charge was present on one piece of charge tape. We made a few simplifying assumptions, one being that we treated the tape as a single point charge. In this lab, we'll be removing that assumption and distributing the charge evenly across the length of the tape in our model. So that's going to be a more sophisticated model and calculate a more accurate value for the charge of the tape. In the previous point charge model, I found the charge of the tape to be approximately 1.5 times 10 to the negative 8 coulombs, and in this new model, I found the charge of the tape to be approximately 3.42 times 10 to the negative 8 coulombs. Before I get further into this lab, let's take a minute to review the fundamental physics principles one needs to understand in order to complete this lab. So I used Coulomb's law in this lab and the last to estimate the charge of the tape and the point charge model. And then the concepts of superposition, Newton's second law, and Newton's third law are all also present in this lab. In this experiment, several assumptions were made to approximately determine the amount of charge on the floating tape. I assumed that I could ignore air resistance on moving objects. I assumed that each U-tape made had about the same amount of charge since we used the same methods to charge each one. And I also assumed that charge is evenly distributed along the length of the U-tape. Now to get into my observations, I found that the U-tape was attracted to neutral objects. When two U-tapes were placed near each other, they repelled, which indicated that they had like charge. To determine whether that charge was positive or negative, I held a U-tape near a negatively charged pen, and then observed that the U-tape was weakly attracted to the pen, which indicates the tape had a positive charge. When we floated one U-tape above another, we found that the top tape, tape B, began to float when tape A was 2.5 centimeters away. Here are my measurements and calculations. I first measured the length and mass of my U-tape. I calculated the force of gravity on one of the tapes and set this force equal to the electric force to isolate and solve for Q. Finally, let's take a look at my computational model. Again, we're going to be using a new strategy to calculate tape charge in GlowScript. First, I built my model using the Q value I found from Lab 1. I just assumed that one was correct and then started iterating over a number of point charges along the tape. In this case, I used 10 point charges to determine the net electric force. I'm then going to compare the net electric force to gravity and adjust the tape's charge until I find a value for which the forces are equal and the tape is in equilibrium. So I set up my model by adding in my observed values for mass and net charge, as well as my function for the calculation of the electric field. We completed that in Lab 0. I then created my U-tapes and placed a distance of 0.025 meters between them and iterated over 10 point charges distributed along the tape to find the net electric force. Then I created arrows representing the electric and gravitational forces and received this result upon running my code. You can obviously see that the system is not in equilibrium. The gravitational force is actually larger here than the electric force. So I began increasing my value of Q to find a value for which the forces were equal. And after some trial and error, I found that a Q value of 3.4155 times 10 to the negative 8 coulombs would give me a model that was in equilibrium where both forces were equal. Now for some final questions. What if you had modeled each of your tapes as a single point charge like in the previous lab? Well, in the previous lab, I found an estimated value for the charge tape to be 1.54 times 10 to the negative 8 coulombs. And in this new and improved model, I found an estimated value of 3.4155 times 10 to the negative 8 coulombs. So that's a 120% increase in the value of my charge between the two labs. Why do these estimates differ? These estimates differ because, again, in Lab 1, we assumed that all the charge in the tape was concentrated at a single central point. That's obviously not how charges behave in real life, so the value calculated in this lab is more likely to be closer to the real value because that line charge model more accurately depicts how charges behave in real life. Thank you so much for listening to my Lab 2, and I look forward to completing Lab 3. Thanks.